Alright, today we're going to start with our trigonometry unit, and today what we're going to do is we're going to look at reviewing basic trig using SOHCAHTOA and Pythagorean theorem and things like that. And then the next few lessons we're going to look at new stuff, sine law, cosine law, and so on. So a couple of quick things to remember. First thing, make sure your calculator is always in degree mode when you use any kind of trig, any kind of sine, cos, or tan, it has to be in degree. And on a graphing calculator, just go to mode, and just make sure you got radians and degrees are the two choices. Make sure you're on degree. And remember how to label a triangle. So if we have angle A, we say side A is across from it. Angle C, side C is across from it. Angle B, side B is across from that. And if we said we're looking at angle A, then A is our opposite side, B would be our adjacent, and C is our hypotenuse. C, the hypotenuse, remember, is always across from our 90-degree angle. So those are kind of common things that you need to remember. Other than that, our other two sort of main ideas are Pythagorean theorem. So for any right angle triangle, our two sides, our legs of the triangle squared will add up to our hypotenuse squared. And also any three angles in a triangle, ABC, always add up to 180. And then other than that, our three basic trig ratios are SOHCAHTOA, sine, cos, and tan. So our sine is from angle A we're looking at. Our sine would be opposite over hypotenuse. Cosine is adjacent over hypotenuse. And then tangent is opposite over adjacent. And then if we're looking at angle B, for example, our triangle sort of changes a little bit. So from angle B as our reference point, this time our opposite side is that one, and our adjacent would be that one. So it changes a little bit depending on the angle, but just always stick with the formulas and you should be good. So this first example, we're looking for length AC. So we're looking for side B. That's the opposite to angle B. So if we look at our formulas, we got opposite of B, and 13 would be our adjacent. So we would have tan. So tan 27.
Jacob Lawrence, could you please come to room 300? Jacob Lawrence.
So tan 27, opposite over adjacent, would be B over 13. So our answer then, to solve this, we just cross multiply. So B would equal B times 1, which is just B, would equal 13 times tan 27. So just type that in on your calculator, and we get an answer of 6.6, and it'd be centimeters because it's the same units as the other side. And the only thing we want to remember, you're going to see questions where they're going to give you terms like angle of elevation, and remember we just measure that from the ground up. We think of elevation as going from the ground upwards, so it'd always be drawn like that. So if we had a triangle like this, and I said the angle of elevation is 12 degrees, that 12 degrees would be down there at the bottom. Okay, let's try another one. So here we've got 40 degrees, so we have our opposite side is 9, and in this case our adjacent is unknown, but we're looking for our hypotenuse being x. So we've got opposite over hypotenuse, so we would use sine. So sine 40 would be 9 over x. This time when we cross multiply, we'd have 9 times 1, which is 9, and then we would divide by sine 40. So just be a little bit careful when you're solving these, that you get your multiplying and dividing done correctly. So 9 divided by sine 40 gives us 14 in this case. Okay, next one, same sort of thing. We've got 60 degrees. We're looking for side x. So you can see from the 60, we don't have the opposite side this time, right? Opposite isn't given to us. We have our adjacent and our hypotenuse. So using SOHCAHTOA, we would go cosine. So x will be 13 times cosine 60, which is 6.5. And it'd be centimeters again, because that's what was given to us in the question. So that's kind of gives you an example of each. Finding angles now, same sort of idea, except we just got to be careful when you type it in. So in this case, from our angle, we've got our opposite, we've got hypotenuse. So we'd go sine theta equals 14 over 20. So now to do this on your calculator, we got to undo the sign, so that's where we have to go second sign. So type in 14 divided by 20, second sign, and That gives us an angle of about 44 degrees. Okay, so this angle, and I've got another note on here, in this case we'd call that the angle of depression. So angle of depression is always measured from the horizontal. So let's imagine you were like standing on the top of a cliff or something. So as you're up at the top of the cliff, you're looking downwards. So the angle of depression is from looking straight across and down. So it's always measured from the horizontal downwards. So if you're looking down at a boat or something that's down below, that would be your angle of depression. So another type of question you're often going to get, it'll say to solve a triangle. So when we're solving triangles, what we're looking for are all missing sides and all missing angles. So we can see in this case we're looking for side A, we're looking also for side C, and we'd be looking for angle B. It doesn't matter what order you do them in, just pick and go. So let's start with the angle, because we know if this bottom angle is 90, so we know all angles in a triangle add up to 180. So we'd have 180 minus 90 minus 43 gives us 47. So we know angle B has to be 47. Then we can figure out, let's go with side A next. So from our 43, we have opposite and adjacent. So we can go tan 43 equals A over 11. So 11 times tan 43 gives us 10.3 approximately. And once we have that, we can find C. Let's just use Pythagorean theorem for C. So that would be 10.3 squared plus 11 squared, and then we square root our answer. And that gives us about 15. And that's it. So any of these kind of questions, if just basically solving, you're just using any SOHCAHTOA, Pythagorean theorem, or the 180 rule works fine. So this next, our last question I've got here is, looks like a weird shape, but we're looking for angle B. So we're trying to figure out what that total angle is. So you can see we've got basically a 90-degree angle triangle here, and if that's 90, that means the other side also has to be 90. So basically what we can do is we can actually solve each of these little mini triangles. So at the top, we've got 4 by 3 and a 90-degree angle like that. So we can solve for that top angle just using sine. So we'd have sine, let's just call it x. So we'd have sine x is opposite over hypotenuse. And once again, remember, we got to go second sine 3/4 to solve that. And that gives us 48.6 degrees. So that's our top little part there. And we can basically do the same thing for the other one. We know that if we can solve for the other little angle, then we just add the two together. So our last little step for this one would be, well, we can kind of look at the whole triangle. So if that's 48.6, the other one is 90. So we know that this other little angle then has to be 41.4 because they have to add up to 180. And then in the big triangle, no, that's not going to work. Let's see what else could we do for this one. If we figure out the missing height, that's probably going to be our better bet. So if we figure out what that shared height is, so if we look at this total distance here, once we have that, then we could actually solve the other triangle. So let's do that part first. So let's stick with the 48.6 we just solved, or we could use Pythagorean theorem, that would work too. Let's do that. So in that triangle we have 4, 3, and we're looking for this other side. So we can just go 4 squared minus 3 squared. Square root that gives us square root of 7. And we'll leave it as a square root of 7 just to keep it a little bit more accurate for the time being. So now, once we know that that's root 7, we can actually solve for our top angle now once again. So our top angle will now be adjacent over hypotenuse. So we'd have cosine angle x, or whatever we want to call it, would be adjacent over hypotenuse, which is 3. So if we go root 7 divided by 3, second cosine, that gives us 28.1 degrees. So if the one half of the angle was 48.6, the other half is 28.1, add those two together, and that gives us 76.7 degrees total. Okay, so a lot of these kind of questions, you're just basically going to have to do a little bit of multiple steps to figure out the missing sides or missing angles and so on. Often when you get a question like this, anytime you have triangles, like two different triangles, and they're sharing a side, usually you're going to have to figure out that height or whatever that shared side is first. So you'd use one triangle to solve for that, then you take that answer and put it in the other triangle to solve. And that's all.